Okay, this is a brief lecture on unions, which is the latter half of your chapter 10 in your textbook. And I'll go over the author's example. And so I went ahead and print the author's disclaimer. Since I'm using his example, his examples, Dietl and Associates, it's their copyrighted material. So I feel compelled to say that at the beginning of this YouTube. So, I like to put some artwork in the beginning of my presentations, and so I Google images on unions and I get a bunch of labor union stuff or credit union stuff. So nothing too fun this time. So what is a union? Well, it's another derived data type, like a structure is a derived data type. We had the fundamental data types, int, double, char, those are fundamental C data types, and then we have some that are derived, such as the structure, and now the union. So what is a union? It lets you define several variables that occupy the same memory area. And you think, well, why would you want to do that? Well, an example might be that maybe you want to access the same data at different times in your program, but the data that's stored there might be of different types at different occasions depending on the program. So you might also have a group of variables that are, say, all numeric data types, but at some point in your program you might want to treat that simply as an array of character elements so that you can move them about as a single chunk of data. So that would be examples with decent programs of where you might use a union. So let's go over the very simplistic example in your textbook. So first let's start with how do you declare a union. It's similar to how we declared a structure in its form in a way, because you have the data type is union, the tag, or like the name, the identifier, the tag name in this particular union is called number, and then inside here you have the body of what's in this union, or the variables that are defined inside the union. So the union is a data type. It's a derived data type. This particular union is called number. It's not usable right now, so you have to actually define an instance of the union. In this case, we're going to say, okay, now I have a union of type number, and its name is going to be value. So now I can use the union. So similar to how we did structures is kind of a similar form now with unions. So let's see how we use the union now. Oops, I didn't mean to put that up. So take that away for a moment. So here's my union called value, and now I'm going to put some values into the union. So remember the union has an int x and a double y sort of at your disposal when you start using the union. So here I'm going to say value.x is 100, which is an int, and down later in the program you'll see there's a value.y will also be a 100, but y is a double, so there's a decimal point and a 0 in it. But anyway, so now I give value.x the value of 100. I print it out, but I printed out both what value.x is and value.y is. But remember, I put value.x is 100. Now down here, I assign 100.0 to value.y, and I'll again print the two values out. So this is the result. The result is here. So when I put in an int, then value.x is 100. It was an int, but the double value is not being used right now, so y is 0. And then I go and now give y a value, value.y is 100.0, and it'll print it out. So when I ask to see these values, it's using the same memory space, but it will print out the appropriate value. Now it's interesting that when you look at a textbook example, this double value shown is a monstrous number, and on my system I don't get that. So there was a slight difference there. Textbook didn't have any really great examples of using a union. It was, in my opinion, a little bit of a lame example. So I will continue to search for an example that's a little bit better, but this is my brief and very brief lecture on unions. Gee, this is the shortest YouTube I've done. I think it's all of 5 minutes. Okay, but the next one is 45 minutes, so that'll make up for it. Bye now.